Hello, this is question 7 in the 2009 MAT. We have considered sequences of the letters M, X and W. Right, it's going to be probably one of these other permutation questions. Valid sequences are made up according to the rule that M and W can never be adjacent in the sequence. So M, XM, XW, XMM, XW are all valid sequences, whereas MW, yeah, okay, fair enough. That's just an example of what they said. Clearly, there are 3 valid sequences of length 1. Yes, M, X, and W. List all valid sequences of length 2. Right, so we just need to perm these letters without putting an M or a W next to each other. Okay, so that should be easy enough. So valid sequences of length 2. So we're going to have M, M, W, W, X, X, then M, X, X, M, and WX, XW. Is that all we're going to have? Are we just going to have 7? Yeah, I think we're just going to have the 7 of them, aren't we? Because and then we can't have the MW or WM. Yeah, so that's fair enough. Okay. Let GN denote the number of valid sequences of length n. Further, let MN, XN, WN denote the number of valid sequences of length n that start with M, X, and W. Okay, right. Explain why Mn equals Wn. So this is the number of sequences that start with an M is the same as the number of sequences that start with a W. Well, M and W are completely interchangeable. I mean, they've got exactly the same rules. So yeah, let's go then for this one. We can say, so for Mn equals Wn, we'll say, well, that is because of symmetry. Always useful in these things. So we can say that M and W have exactly the same rules. So if they've got exactly the same rules, they must have exactly the same outcomes for everything. Right, so that's done that one. So Mn, the number of the M valid sequences starting with M is Mn is equal to Mn minus 1 plus Xn minus 1. Right, so what does this actually mean? So the number of valid sequences beginning with M of length n is equal to the number of valid sequences beginning with M of length n minus 1 plus the number of valid sequences of length n minus 1 beginning with X. Okay, all right, yeah, okay, so this would make sense. So if we've got a sequence beginning with M, so we've got M and then something coming after it, then these starting letters here must be another M or an X because we can't have a W. So that's going to be a sequence of length 1 shorter beginning with M or a length of 1 shorter beginning with X. Okay, right, so how are we going to explain this? So any valid sequence beginning with M, because that's what they're asking about. So any valid sequence beginning with M is M plus a valid sequence of length 1 less of 1 shorter length of 1 shorter length beginning with M or X in brackets not W, just to make that clear. So yeah, it just drops out from that. So yeah, it's not obvious, but you put these equations into words and then they kind of say what's going on. We're going to have a similar thing here then by the look of it in the next one. So Xn, the number of valid sequences beginning with X, is then twice the, well, it's going to be, I mean, we can see on this, let's just put this out for the next part then. So we're going to say that Xn is going to be equal to Mn minus 1 plus W n minus 1 plus X n minus 1, because there's no restrictions on what can come after an X. And we know that M n minus 1 is equal to W n minus 1. So we can say that is 2M n minus 1 plus X n minus 1. So yeah, it just falls out from that. Write down a formula for Gn in terms of Mn and Xn. Right, so what was G again? G is the number of valid sequences of length n. Right, so we just got to add these up then. So Gn is equal to Mn plus Wn plus Xn, because it's all of the valid sequences, and that's going to be, we need to eliminate Wn, well it's 2Mn plus Xn. All right, okay, that was good. Hence compute G3 and verify that G4 equals 41. Okay, so right, G3 is equal to, well, we've got it all here, 2M3 plus X3. And then we've got the, where do we have M3? Well, yeah, what are we going to do with M3? We've got this written somewhere, haven't we? Here we go, this thing. So M3 is equal to we've got 2M3, so we'd have 2M2 plus 2X2. And we're all right with 2 because we've written them all down up here. We've got all of our options there. And then we need to add X3, which is 2M2 plus another X2. Okay, so we've got 4M2 plus 3X2. So M2, how many sequences did we have up here that begin with M? We've got 2 of them, MM and MX, so that's 8. And how many do we begin with? X, XM, XW, XX, plus 9, so that's 17. Right, so we need to do this again for G4. Right, I'm going to write out the first description of G4 and see if I can fit it all into one page, otherwise I'm going to run off the screen here. So G4 then, G4, let's squeeze it on there, is going to be equal to 2M4 plus X4. And 2M4 is then 2M3. Actually, it's going to be this line with 3's in. So 2M3 plus 2X3 plus 2M3 plus X3. So I don't know why I wrote out that line. I could have just written out that line, seeing as that was the reduced version of it. So we've got 4M3 plus 3X3. Okay, which means we've got, oh my word, right, 4M3. Yeah, my word, right, so that is going to be 4M2 plus 4X2, and then we've got 3X3 is 6M2 plus 3X2. So we've got 10 M2s, which is 20, plus 7 X2s, which is 21. Hey, which is equal to 41. Right, okay, so far so good on all of this. I think that, does that finish that end bit of the question? Yes, we finished part 2. Let's get a fresh sheet in order to go to the next bit then. Given a sequence using these letters, we say it's reflexive if the following operation on the sequence does not change it. So reverse the letters in the sequence and then replace each occurrence of M by W and vice versa. Right, so M, X, W and that and that and that are reflexive and those aren't. Right, so let's just show what's going on here then. So if we've got, what have they given us? MXW, so we've got MXW, reverse the letters in the sequence, WXM, and replace each occurrence of M by W and vice versa. So the W becomes an M, the M becomes a W, and we're back where we started, and that's then reflexive. Okay, let Rn be the number of valid reflexive sequences of length n. Right, if a sequence is reflexive and has odd length, what must the middle letter be? Right, well, it's certainly pointing us towards it being an X, because they put X's in the middle of all of these ones. Explain your answer. So what are we doing then? We're reversing the sequence, and then we're changing, if it's an M or a W, we're changing it, but we need to get back where we started, right? So that does make sense. The middle letter, so the middle letter does not change position. That's the thing, isn't it? Does not change position. Change position, therefore it cannot change. It cannot change from M to W or W to M in a reflexive sequence. So it must be an X, therefore X, middle letter. Okay, right, so that's got us kicked off. Hence show that Rn, the number of valid reflexive sequences of length n, is equal to these values if n is odd or even. So we're adding 1 to it if it's odd, so we're making that then an even number that we can then divide out. Okay, and it's got something to do with a middle letter. Right, so what's happening here in these sequences then? Let's have a look at what we've got. If they're odd or even, let's do a little bit of a, I'll put this in blue as a, let's see what's happening. So they've given us an MXW, they've given us a WXXM, and an XWXMX. So they've said these are all valid. So they are then looking at strings beginning with, well, let's look at actually I think the even one's going to be the easier one to look at first. So they're saying, so this is of length 4 and they're wanting the number of strings that are then of length 2. So we're splitting it in half, and we are going to have XX in the middle for the same reason, because, well, you can't have any, that's why they've discounted this one with this MX, because if you've got an MX in the middle and you flip it, you'll get XM and then you'll get XW. So that is going to be different. You can't get back to the start. So we can say, similarly, let's just tag this on to what we've just done. Similarly, the middle 2 letters of an even length reflexive sequence must be XX. Even length reflective sequence must be XX, and that's because M and W, MW or WM, not allowed. Yeah, if you had one of those, then when you flipped them over and then changed the letters, then you'd be back where you started, but you're not allowed an M and a W next to each other, so we can eliminate those. Right, so if we've got XX in the middle of these, so we've got a sequence, the second half of which must be starting with X and must be half the length. So that's got to have something to do with this. So let's say how we construct a reflexive sequence then. Therefore, to construct a reflexive sequence of even length n, we take you take a sequence, take a valid sequence beginning with X, because we're always going to need that for the second half of our sequence, beginning with X and length n over 2. So that's got the second half of our reflexive sequence. So let's put that in. This is second half of reflexive sequence. Then what do we do to get the first sequence? So to construct a reflective sequence of even length n, you take a valid sequence beginning with X. Yeah, we definitely got that. Then we're going to need to reverse the order, then duplicate, reverse order, and flip M's to W's, and do M to W and vice versa. Then we stick that on the front of the string. Yes. Then add as first half. of reflexive sequence. Okay, right, so that's how we construct a reflexive sequence of length n when n is even. Right, so off of that, if that's how we construct it, we're doing that all off of the number of sequences, valid sequences, beginning with x of half the length. Right, okay, that's fine. Therefore, Rn equals xn over 2 for n is even. Right, so how are things changing then for odd? Right, what's going on then with odd sequences, odd length ones? So in the case of odd, we've got this extra x that's sitting in the middle. So we're going to be having, what are we doing? So we're saying it's like you'd added 1 to the length. I mean, I suppose it is, isn't it? Because you could, it's like we're ignoring that last x. So we take the x that's in the middle. So for this 5 length one, we take those 3. Then what if we were doing exactly the same thing for an even length? You take that set and you duplicate it, you flip the order, then you add it on, and then you just drop the x off. Yeah, so it's like creating an even length sequence, but you remove one of the x's at the end. Okay, right, so for odd length sequences, odd length reflexive sequence, do the same thing for n plus 1, and then remove one middle x at the end. And if you do that, then you're going to end up with your odd sequence, aren't you? Because we could just start off with an xmx, duplicate it, reverse the sequence, stick it on the front, xmx, change that m to a w, xwxxmx, and then just drop one of those x's, and then we're in there. Right, so that works as a process of doing it. So therefore, we're just going up to the next one up because we're doing an n plus 1. Therefore, Rn equals xn plus 1 over 2 for n is odd. Right, okay, so that was tricky, but it's like we get on all of these permutation ones where you just got to try and spot the pattern first. And once you've spotted the pattern, then you're all right. And go through those steps. You know, when you're spotting the pattern, how are you going about doing it? How are you constructing one of these things? You know, how would you have made one of these sequences? And if you can talk through that process of this is how I make one, then you'll be able to see, hopefully, or at least it's giving you the language, I suppose, is what I'm getting at here. It gives you a way to structure your answer, because explaining your answer is often the most difficult part of all of this. But if you've got a step-by-step process of how you're actually building up these permutations, then you can walk through that step-by-step process in your answer, and it's communicating it to then the person who's marking it all, who's reading your description. So it's like you're working through it, like talking out loud. This is how I build one of these reflexive sequences. I keep calling it reflective rather than reflexive. But yeah, this is how I build one of these reflexive sequences. So let's go through step by step, exactly as I've done here with this is how you construct one of even length. So you take a valid sequence, you begin with x, halve the length, duplicate, reverse, swap the m's and w's, then add it on to the first half. You've got those steps that you're going through. That's then going to lead you to some way of reaching that equation, that relationship between Rn and Xn. So yeah, I'd say that was quite a tough second part to that question. The first part was fairly straightforward, but the second part, I would say that was pretty involved. But still, that's brought us to the end of 2009 for a paper, so onwards.